We have been talking about SQL operation as if it's just one single command set that you will just pick up any single SQL statement and run. But in fact, there are two different types of data usage. And these two data usage patterns are very different from each other. The first type of data usage is called online transaction processing, or short as OLTP. This includes transactions such as sales. For example, you go to a grocery store. Each time the cashier scan one item, this is one transaction, right? Then when you do a web purchase, you click the submit button, submit an order. That's one transaction. And when some UPS or FedEx guy come to your door, ask you to scan to sign agreement that to sign acknowledgement that the delivery is done. That's another transaction. These are transactions that happens on real time. They requires like short and fast processing. So they usually require a small table, only containing a limited number of related data. Only containing, for example, if you are doing a sales operation, you probably only want to have like 2 months of data, 1 month of data, 1 week of data. As soon as the order is delivered, you don't really care. Of course, if you need to wait to make sure that there's no return order, maybe you want to keep it for 3 months. After 3 months, who cares what order is, right? And so you will have a small tables running shallow queries, usually just a quick insert, quick delete, and a quick select. You don't really do a long query with which joins 5 tables altogether, right? The other types of data usage is called online analytical processing, or OLTP, OLAP, OLAP. As the name suggests, it's analytical. So it's complex data, pulling of historical data. In this pattern, you will try to analyze patterns of existing transactional history. You want to go back to like 2 years, 1 year, 6 months to check what's going on. Is there a trend? What's the total number of sales? Is there a trend in the transaction? Is there a certain pattern that some items are selling much better than others? Or is there a pattern that when certain events happen, the stock price will go up or down? These are questions that can only be answered by complex analysis. You do requires like over a range of attributes in order to identify a potential pattern or a trend. This requires long and complex processing. And when we say long, first of all, the query takes a long time. And also, it's a pretty wide select. You will have like 10, 20, 30 columns in one select. And the complex processing means there are a lot of tables joining with each other and with a lot of conditions. So this requires a large table containing historical data and lots of attributes. And these are deep query where you will go several tables. You will link several tables together in order to get a pattern. As a data scientist or a data science student, you are more interested in the OLAP side or analytical side of data usage. So this is why we want to see what kind of analytics, what levels of analytics we have. Usually there are 3 levels of analytics. The first is called query and reporting. Query reporting basically means just running a quick SQL and list out what's going on now. If you are a data scientist, if you're a data analyst, you frequently open up some web page and see a report. For example, if you go to Yahoo Finance, you open up a stock opening. You will see you open up any stock, any ticker. You will see like a 10-day or 1 month pattern, 1 month curve of this stock's closing price, right? This is query reporting. You are reporting the closing sales price of this stock. So this requires some of filtering, but in the end, it's about simply displaying the data, the raw data, or with some light processing. So this is what we call query reporting. You use different ways, either a table or Excel-like table, or some kind of visualization to display the data, the raw data, or some lightly process the raw data. And this is what most data scientists hate to do, but they have to do it because data business requires this information. Sales department want to see the sales. The financial department, accounting want to see the ledger or cash flow. So this is the first level of data analytics. By displaying the operational data, you are providing users an insight into the daily operation. The second level of analytics is OLAP, or sometimes it's called the business intelligence. This includes a lot of data massaging, data manipulations. You will do a sorting, slice and dicing, which means you will do a lot of filter, like for example, sales data, you want to slice it, list the sales data out by product or by, by city. Then you will also do pivoting, converting the format. You will do aggregation. You want to see the sum up, the sales in different zip code, etc., etc. And this is what most data scientists will do. Data scientists will do the slicing and dicing and find patterns to provide these patterns to management. And finally, there's this data mining, analytics, and statistics. In modern terms, they are called machine learning or artificial intelligence. But in fact, most people are still just doing the simple statistics. This is what most people, they want to do, and they want to label themselves as machine learning or artificial intelligence. But in fact, very few people are actually doing artificial intelligence or machine learning. They so I think this slide, I want to give you an overview of levels of analytics and what you should expect in your future job. Majority of time, you will be doing query reporting, supporting query reporting, creating reports to the business users, and do some business intelligence, and do some kind of sorting, aggregation, and and pattern recognition. But most of you will not be working on the machine learning and artificial intelligence side. No matter how much people are talking about it these days, it's not going to be really what the whole industry is doing in the next few years. Unfortunately, this is the case. Now, regarding the statistics, right? There are something that I still want to talk about. Although I do not see, I do not see this artificial intelligence or machine learning thing be popular in the next few, be mainstream in the next few years. I still think this is the direction where you need to look at, for the simple reason that by working on machine learning and analytics, you will have a much better understanding of the data. So artificial intelligence and machine learning may not be what your requirement, what your work job requires, but it will definitely be the right thing to do in order for you to move yourself forward, higher in the career ladder. Okay, let's go back to BI and OLAP, business intelligence and OLAP. There are two types. When OLAP was first invented, there are two types of OLAP, which is relational OLAP, ROLAP, and the other is a multi-dimensional OLAP, which sometimes is called ROLAP and MOLAP. The difference is really, where does the analysis happen? If you run the SQL query in the database and gather the data there and just do some simple operations for afterwards, this is called OLAP. The good news, the good thing about OLAP is it's running directly against the database. So you will have all the data available, right? But because you have all the data available, it may be slow. And because you run SQL only, you will have less functionalities. Or you can pull the data and store that in a particular software vendor's memory. And this software vendor can provide you with more statistics and more analysis functionalities. This is called MOLAB, multidimensional OLAP. The good news, the good thing about the advantage of MOLAB is that it's it provides more functionality. And it's faster because everything is stored in the vendor's server memory. But it has the downside of it is because you are pulling data from database, you will have a limited data volume available. So these days, so there were some arguments about which one is better, MOLAB or OLAP. But as we can see, both have some advantage, right? So these days, most vendors are hybrid or OLAP. They will have a MOLAB infrastructure for the most commonly used data. They will pull data from database maybe once a day or once an hour, and create some analysis, store that in the memory, and create some pre-calculations so that the data scientists can access them in a more faster fashion. They also provided a OLAP function if the data requested is not available in their MOLAB system, then they will go to the database and run the OLAP and get the data. So right now, most of us are using a OLAP approach. So for OLAP, it's simple, right? It's a relational. You just run the database, you run the SQL against the database. But MOLAB, there are some additional characteristics that you may be looking at. So first of all, when you store the data, when you store your data in the vendor's server, vendor's machine, you will have multiple methods. But because BI and OLAP is mostly used for data analysis, so there are a lot of sorting, slicing, and aggregations. So the data are usually stored along the attributes, along the value of attributes, which is called multidimensional and multi-level. When you place like different data, like building blocks, and try to sort them out from different dimension, it looks like a cube. That's why these kind of MOLAB data set are usually called cubes. So you will frequently see the name cube when you are using certain business intelligence vendor. In most of the business vendor, they have this name of cube. These cubes are data sets that have dimension listed out and calculated. Now, MOLAB also have the advantage of getting data from multi-data sources. When you do OLAP, usually you only get data from one or a few relational database. The advantage of MOLAB is that you can get data from multiple data sources and combine them integrate them into one cube. So your MOLAB function, your MOLAB vendor is actually pulling data from multiple places and create their own data. For example, in Microsoft Analytics services, you can actually import like Power BI. You can import data. You can import your Excel. You can read data from SQL Server. You can read data from multiple places and combine to create your own cube. And because of this, because of both of the above, one is you want to create a multidimensional cube. Another is because you will need to combine data from multiple data sources. Usually the cube size are pretty big. it requires a lot of database, storage place, hard disk, and memory. For this reason, many vendors are built on as a multi-tier functionality, where you have a server, where you have a multi-host server. So you will have a server and store all the cubes. Then you can have a desktop or maybe a browser accessing the server. And sometimes the desktop itself can also access data from the data source and perform some simple, less memory intensive work. So when you use your BI vendor, you may want to check what's a desktop and what's a server, and getting data from the server for further analysis. And the other thing about that people usually talked about these days is visualization. Visualization means putting data in a more intuitive way, like graphical way. Now, visualization itself is not a level of analytics. Visualization is a tool, it's an approach, it's a method. It's not a level of analytics, but it can be applied to all analytics, right? For example, it can be used in query and reporting. You can have a daily price chart, daily price trend of a stock, of a certain stock ticker. And it can also be used in BI, OLAP, where you can display a certain format, certain function, like a column chart, a pie chart, something like this. So it can be used across different fields, and we will have a course dedicated to visualization, I believe.